All right, we're taking a look at lesson 4.5 today. 4.5. What specifically, it's going to be looking at graphing other trig functions. And though we could use the calculator for almost everything, there's one thing the calculator cannot do, and that's asymptotes. That's where I'm going to spend my time today, is we're going to look at vertical asymptotes. That's what's new. But before we get to what's on deck, what's new, let's take a look at our bell ringer here. Simple question for number 1. Find the coordinates that describe the maximum and minimum values. So I say simple, and what I mean by simple is we could place the dots very easily and say, okay, I can see the maximum, I can see the minimum. The question comes down to writing it in the correct form. We have to write the coordinates, and when by coordinates we mean the XY pair. So let's take a look at this maximum value. For the maximum, what would be its coordinate pair? Is the 1 the X or the Y?
The Y.
That'd be the Y. Very good. So that's the Y value. What would be our X value here? Because it doesn't show on the X-axis. Not all at once. If we skip the value here.
Pi over 2.
That's right. It's halfway to pi, so this would be pi over 2. And so our X value for the max would be pi over 2 there. Now let's take the minimum. This might not be quite as intuitive. You might have to kind of think on this for a little bit. Maybe not. Maybe this is for you. I can get the Y value pretty simply. The X value, though, we might have to think on just a second longer. So I'll count differently than how that. Right now we can see on the X-axis it's saying pi over 2 pi and then 2 pi. I'll count this way. This is like 1 pi over 2. 1 pi is the same thing as 2 pi's over 2, or 2 halves pi. That's 1/2 pi, 2 halves pi. That would then make this one be, that's 1/2, 2 halves. This would be
3 pi over 2.
3 halves. So we'd have 3 pi over 2. And then we could end at this point at, this would be 4 halves. 2 pi is equivalent to 4 halves, 4 pi over 2. Okay, number 2 though, it says now let's find the coordinates that describe the maximum and minimum on the graph if the domain is listed from -2 pi to 0. So let me come over here and point out that the domain here was from 0 to 2 pi. This was from 0 to 2 pi is where we just did the domain, what we just did. So now we're going to take a look from -2 pi to 0. So I actually copied this over to a different slide so I can show you the negative portion of the graph. I'm going to do my best art here to say, okay, what is this sine wave going to do? It's going to go down, back up. Whoa, my hand slipped. Sorry, let's try this again. Back up, and there, I'm going to stop right there. Okay, so art with Mr. Voorhees is never the greatest, but that's my best attempt to draw the left side. So now I have domain for the left side of this graph. And we want to find, again, the coordinates, the X and Y coordinates, that would describe the maximum and the minimum. And I'll remind you, we discovered that this was pi over 2 and that this point was 3 pi over 2. So if we were going to label our negative domain, the left side of the domain, if you will, what would this point be right there?
-pi over 2.
There we go, -pi over 2. And this point right there?
Pi.
I'll be a little more specific. -pi, there we go. This point right here? -3 pi over 2. -3 pi over 2. And then finally, that's super ugly, Let's see if we can get that looking a little better. And then finally, this would be negative 2 pi. Okay, so that maximum would be found at what coordinate point? The x value would be negative 3 pi over 2. The y value would be 1. And then over here, the minimum value would be located at the x value negative pi over 2. And the y value at negative 1. That would be the minimum. And that would be also the bell ringer. Now, before I jump into the new stuff, I've done some work really after your class and right before the start of your class from yesterday. And what I produced over here is what I think is a really neat looking graph of, or a relationship between the unit circle, the graphs of cosine and sine, and I've added recently the reference triangle down below. So how does this work? So last class I was trying to show you this, how the graphs connect to the unit circle, and I was trying to show you, we usually deal with the angle, and for the record, I've called the angle here A. So anytime you see an A on this calculator, it refers to angle, okay? As the angle increases on the unit circle, as our angle increases, shown in blue here, the angle is increasing. This is pointing at how many radians. I'm at pi over 4 right now. That would be pi over 3. This would be like 3 pi over 4. Is it? Okay. As the angle increases, what happens on the graph is the graph moves to the right. That's because the graph, the x-axis is not actually in terms of x as we think of like cosine being x. The x-axis is the angles itself. As you look on the x-axis here, all you see are angles marked. These angles correspond to the angle on the unit circle. So let me go back to like pi over 3, for example. On the unit circle, if I'm pointing at pi over 3 here, then that means the particular position of sine and cosine would be found by looking at pi over 3 on what I'm going to call the a-axis. The a-axis here, or the a radian axis. So at pi over 3, you would get your positions where green would be the cosine, purple would be the sine. So sine has a value of 0.866, that's the decimal. Or you could go right here to the y-axis and determine that is the same thing as the square root of 3 over 2. The cosine value would be 1/2. Okay, now on the unit circle, you would get it from the point. So these two locations right here would correspond to these two. That's the cosine, that's the sine. Now, what have I added since yesterday? If you look down below, I added a reference triangle to show you how this connects. So this was lesson 4.3. This was lesson 4.4 that we've done. So 4.3, 4.4. This was what we did over a lot of lesson 4.1 and 4.2. 4.1 was basically solving with triangles, and 4.2 was dealing with what converting with radians and dealing with this reference angle, what I call right there, a reference angle within the reference triangle. So how does this all correspond? I'm showing you here that x equals cosine A, that y equals sine A, and the h is 1. Now, some students might ask a great question. They might say, wait a minute, Mr. Voorhees, earlier in the year, you told us that, let me just get to this slide. You told us that sine was not simply y. You said sine was y over h. Cosine is x over h. And tangent was y over x. Why are you now telling me that cosine's x and sine is y? What happened to the h? Well, on this particular problem, what is h? You can go ahead and say it out loud. What is h right there?
1.
H is 1. What is, so sine is supposed to be y divided by h. What is y divided by 1? It's just y. And what is x divided by 1? X. So a unit circle, why it's so brilliant, is it simplifies everything by taking away, basically, taking away the h because it sets it equal to 1, which mathematically makes it kind of disappear. So it makes things a little bit simpler to solve. So the y would be the sine value, x would be the cosine. Notice on the unit circle how it goes cosine comma sine. That's how we would use these. So how this corresponds, this little triangle within here represents this one. And so using this together, I could say, hey, what is the sine of 5 pi over 6? And so one thing you could do is you could drag this angle tool over here to where you get to 5 pi over 6. So as I'm dragging this tool, I'm looking on the circle until I see it hit 5 pi over 6. And if I'm forgetting what value is what, this would tell me the x is the cosine. So the x is the cosine. The y is the sine. If I still can't figure it out from my reference triangle, I could go over here and look at color coding. X, the cosine's the green graph, would be the negative 0.866. And the purple would be the sine, 0.5, which is the same thing as 1/2 and negative square root of 3 over 2. So you can look at there as well. So this is how they all correspond. So at 5 pi over 6, 5 pi over 6, the sine is 1/2, the cosine is this decimal, or you could read it as negative square root of 3 divided by 2. That's how these all relate together. And this would work for any point along the unit circle. So my unit circle goes from 0 to 2 pi all the way around. We give you the point. Also shown in red, that's the cosine, that's the sine. You'll notice cosine is a green here. That's the cosine. That's the sine. You'll notice those match up. I put it red just because it's going off the unit circle. It's showing you that point right there in the unit circle. Just everything gets really crammed, so I had to kind of put it off on the side. But that's what the red refers to, is the point right here in the unit circle will be there. Okay, so that's just a tool I've made available to you. Hopefully that helps you out. We've had to find the maximum for sine. So sine is purple. What we could have done is just use this tool and said, okay, my max is right there. It's at pi over 2 comma 1. Is that the answer we got to number 1 for the maximum, pi over 2 comma 1? Look at your paper. You should have written it down, I think.
Yes.
Yeah, that was the maximum. Or you could have said, all right, well, my minimum's down at this low point down here. 3 pi over 2 comma negative 1. All right, let's just say all of a sudden, for whatever reason, the apocalypse hits tomorrow and we no longer can graph. Could we use the unit circle to get the same solution? Yes. If sine is your y, what you do in the unit circle is you look for the lowest y value, which is the bottom of the circle. That's the minimum, negative 1. And it happens at 3 pi over 2. It's hard to see that 3 pi over 2. It's kind of getting overlapped there. That's 3 pi over 2. Or if you need the maximum, you would go to the highest y value, which is all the way at the top of the circle. That's the highest y value. It occurs at pi over 2, and the highest y value is 1. So it's pi over 2 and 1. So again, you could have got the answer from there as well. All right, so that's a little tool. Hopefully that ties together some of the lessons to you see how they all work together. This was lesson 4.3. This was lesson 4.4. This was lesson 4.1 and 4.2, somewhat. Okay, so today